So in this video, I'll be discussing the different empirical gas laws that describe the gaseous state and its properties. I'll also describe the absolute temperature scale and how it was derived from one of the empirical gas laws. I'll also discuss the ideal gas equation and how it was derived from the four empirical gas laws and the basis for the empirical gas laws, which is the kinetic molecular theory. So ito yung theory na nabuo because of those gas laws. Okay? So yung gases, they are one of the 7 known states of matter. Meron actually tayong tatlong classical states, yung solid, okay, liquid, gas. Okay, yun yung mga classical states. Meron tayong mga non-classical states, yung plasma, liquid crystals. Meron tayong Bose, Einstein, condensate. Okay, meron din tayong quark, gluon, plasma. Actually, mas marami pa yung ating nadi-discover na states of matter. Pero ito yung mga mini-mention ko nung sinabi kong 7 states of matter. Okay? So, gases are also fluids. So, hindi sila tulad ng solid na merong definite crystal structure. Therefore, meron silang definite shape. Liquids and gases are fluids. They are capable of flowing and they are capable of long-distance relative motion. Okay? Kasi kapag ka solid, naka-confine ka dun sa crystal structure mo, so yung motion mo ay parang limited lang sa vibration. However, yung fluids, meron silang long distance relative motion or linear momentum. Actually, nakakapag-move from one part of the system to another yung gases and liquid particles freely. Okay? Hindi tulad ng solids. So, positional invariance of the gas particles makes them easy to model. Ang problema din sa solids and liquids, okay, they have two parts. Meron tayong surface and bulk. Okay? Ang gases, walang surface and bulk. Ano ba yung ibig sabihin ng surface and bulk? So, kapag ka liquid, meron tayong surface ng liquid and meron tayo yung ilalim ng liquid. Surprisingly, meron silang dalawang magkaibang properties. Actually, there is a property that is dedicated only to the surface of the liquid. That's the surface tension. So, walang surface tension sa bulk. Okay? So, it means that it's very hard to model liquids and solids due to this separation of material parts. Okay? Mahirap. Mas kailangan mong separately i-model tong surface and bulk para ma-describe mo yung kabuuan ng isang state. Hindi tulad sa gases, kahit saan ka tumingin dun sa system, it is representative of the rest of the system. So, kung tumingin ka lang sa isang side ng jar, yung mga moving particles doon, you can assume, okay, with valid confidence na kapareho yun nung nasa ibang part naman ng jar. So, ganun ang gases. It's very easy to model because they are just moving particles na walang distinction sa position and sa part ng system na kung nasaan man sila. So, wala silang positional invariance or meron silang positional invariance. Okay? Hindi nakadepende sa position nila at any point in time yung properties nila. So, wala silang surface bulk components. The property does not depend on the 3D position of particles. Sadly, ito yung state natin kapag sa solid. Okay? So, even the same compounds have different properties pagka magkaiba sila ng crystal structure. So, bulk properties of the whole system is representative of each gas particles. Ito yung kaninang analogy na diniscuss ko. Okay? So, let's proceed. The earliest studies of gases came from the 17th century AD. So, 17th and 18th century, nakaka-discover tayo ng mga gases. These are just 4 of the examples. Ito yung mga gases na na-discover and these are the discoverers. So, you'll remember Joseph Priestley. He disproved the phlogiston theory because of his discovery of oxygen. So, the first gas law that was discovered is Boyle's law. So, Boyle's law states that the product PV is constant, okay, at constant temperature and number of moles. So, isothermally, ang PV ay constant. So, ibig sabihin, yung pressure is directly proportional to the inverse of the volume. So, kapag ka nag-drawing ka ng isotherm and you plot P versus V, the relationship is inverse. Pero kapag ka pinlat mo yung P versus 1 over V, it's linear. And the slope is constant. Okay? So, based on the gas law, meron nakitang parang curious relationship si Boyle. Okay? So, as you decrease the pressure, okay, Of course, the volume will increase. Okay? So, nag-increase yung volume, nagde-decrease yung pressure, pero nag-a-approach yung product na PV, okay, sa isang constant. So, this three gases were measured at 0 degrees Celsius. So, meron silang ina-approach na value. Actually, this value is 22.4 liters per mole. Okay? Nadi-discover natin mamaya kung para saan yung 22 liters per mole na yan. Okay? So, yun yung na-discover ni Boyle. So, at decreasing pressure, nagkakaroon ng certain value yung PV. Nagkakaroon siya ng constant value, or at least nag-approach siya sa isang constant value, not temperature dependent. Kasi kapag iniba mo yung temperature na to, ibang value naman yung i-approach ng PV at low pressures. Okay? So, other gas laws, Charles' law states that the volume is directly proportional to the temperature at constant pressure and number of moles. So, Jacques Charles was the first man to fly using a hydrogen-filled balloon. So, this was not a good idea kasi because of the Hindenburg incident, yung airship na sumabog because it's filled with hydrogen. Ngayon, ginagamit na nila ay helium. Okay? So, next is Joseph Louis Gay Lussac. He discovered the Gay-Lussac's law. Okay? Pressure is directly proportional to the temperature at constant volume and number of moles. So Gay-Lussac developed the effective design for pipette and burette. He also developed the method of standardization. Okay? So based on the Charles findings, okay, gumawa siya ng model that will relate volume and temperature. Pero yung temperature scale natin kasi ay Celsius, kaya medyo weird yung model. Hindi siya simpleng Charles law lang. So, gumawa siya ng ganyang model for the temperature scale or the degree Celsius temperature scale. And he used a certain constant parameter called the thermal expansion coefficient. This is 1 over V times the change in the volume with respect to the temperature at constant pressure. So in thermal expansion coefficient describes the degree of increase in the volume per unit increase in the temperature. Kasi magkakaiba yan sa magkakaibang gas. Pero kapag ka nasa certain condition ka of pressures, halimbawa mababa yung pressures mo, nag-a-approach sa ganitong value yung thermal expansion coefficient. So using this common approximate value among different gases, okay, dinerive niya yung value ng temperature if V, okay, is equal to 0. So, if you plot the Charles law diagram or graph, okay, so this is temperature and this is volume. If you go, okay, this is volume equals 0, okay, the temperature is equal to negative 273.15 degrees Celsius. So, yun yung na-discover niya. Okay, so the absolute zero temperature. Siyempre, hindi naman na magkakaroon ng negative volume. So, ito na talaga yung lowest temperature possible according to Charles' law. So, pwede na tayong gumawa ng temperature scale na merong lowest value. Okay, ito na lang kaya yung gawin nating 0. Okay, so gumawa si Charles ng Kelvin temperature scale, or at least mga colleagues si Charles, okay, or yung mga scientists after him, gumawa sila ng temperature scale na meron ng lowest value. So this is 0 Kelvin. Okay, so you know this already. Kelvin is degrees Celsius plus 273.15 degrees. Okay, so yun yung absolute temperature scale. You also know that there is the Rankine temperature scale. The Rankine is equal to degrees Fahrenheit plus 459. Okay, so 0.67 degrees. Okay, so yan yung derivation ng Rankine or yung conversion factor niya. Okay, so ito na yung Kelvin temperature scale. So, Gay-Lussac's findings was also interesting kasi he discovered that gases tend to combine in whole number ratio. So, this is a law of definite proportions. Okay? So, hindi lang naman siya yung nakadiscover ng law of definite proportion, pero siya yung nakadiscover nun sa gases. Okay? So, he's using Charles' law to predict the structure or the composition or the chemical formula of compounds based on how many gases combine to form them. So, ang ginawa niya, pinredict niya yung water. Kasi, alam na niya yung chemical formula ng water. It's H2O. So, sabi niya, kung gagamit ako ng hydrogen gas, so kailangan ko ng dalawang volumes ng hydrogen gas saka isang volume ng oxygen. So this is 2 volumes of hydrogen and 1 volume of oxygen gas. Kaso ang lumabas na data plus 1 volume. Okay? So hindi nag-agree dun sa data niya. Sabi niya, edi ibig sabihin, either iba yung molecular formula ng H2O or may mali sa aking assumption about hydrogen and oxygen. Actually, the second one is true kasi he assumed that hydrogen and oxygen are monoatomic gases. Okay? So, syempre, kapag monoatomic gases, natural lang na 2H plus O is H2O. Pero kapag diatomic sila, you'll see that 2H2 plus O2 is 2H2O. Okay? Ito yung mag-agree dun sa kanyang result. So, who told him this particular property of gases? Amedeo Avogadro. So, Amedeo Avogadro was the one who devised a system that would relate, okay, the so-called mass of the gas to its other properties, pressure, volume, temperature, and others. Okay? So, pressure, volume, temperature lang sa point na to. Okay? So, yung mass, ginawa niyang amount. Hindi niya winay yung mga gas. Ginawa niya, binilang niya. Okay? So, he realized that the number of particles is directly related to its pressure, volume, and temperature, not the mass. Kasi yung mass, nakadepende pa yan sa kung ano yung iyong compound or yung kung ano ang iyong atom. Okay? Kasi magkakaibang atom, magkakaiba ng bigat. Pero the same number, okay, of different atoms. Kung halimbawa, meron kang 5 atoms ng helium at 5 atoms ng oxygen, at certain levels of pressure and temperature, pareho sila ng behavior. Okay? Pareho sila ng relationship sa volume. So that's how he discovered the Avogadro's law. So according to Avogadro's law, volume is directly proportional to the number of gas particles or its amount in moles, okay, at constant pressure and temperature, not the mass. Okay? Kasi yung mass, meron pa siyang molar mass na kino-consider. Yun yung kanilang naging distinction depende sa nature. So, he realized that this number is very important kasi it unifies the concept of amount. Okay? You can now correlate the number of moles with the other parameters kasi nabibilang mo na kumbaga yung mga atoms. So, this is Avogadro's constant, 6.02 times 10 to the 23. So, any particles or any entities that is 6.02 times 10 to the 23 is called 1 mole. So, kahit planeta pa yan, kung 6.02 times 10 to the 23 planets, that's 1 mole of planets. So, paano niya nakuha tong number na to? He just weighed 12 grams of carbon 12. Tapos, binilang niya yung mga particles ng carbon 12 using an X-ray machine or X-ray device, okay, diffraction device. Tapos, he estimated the value 6.02 times 10 to the 23. Okay, hindi naman niya siguro nabilang yan lahat. He actually has a method of counting. So, yan na yung tinatawag nating chemists dozen. Okay, that's the mole. Okay, so, to be able to remember 1 mole, you'll celebrate, okay, we celebrate the World Mole Day. Okay, so October 23, that's 10 to the 23, 6:02 a.m. to 6:02 p.m. Okay, so that's 6.02 times 10 to the 23. So that's the World Mole Day, every October 23. Okay, so using all of these ideas and empirical gas laws, we can now derive the value of the constant A, which is temperature dependent. Actually, this A is R. Okay, so R is 0.08206 liter atmosphere per mole Kelvin. Okay, so paano nila nakuha yung R? He set the temperature at 273.15 Kelvin. Tapos, kinuha nila yung 22.4 liters per mole na volume. Okay, so sinubstitute nila yan sa pressure volume. Makukuha mo na yung R. Okay, so it's actually very easy to determine. So this constant can only be used if your parameters are at this unit. So yung volume mo dapat liters, yung pressure mo dapat atmospheres, yung amount mo dapat in moles, and yung temperature mo dapat absolute in Kelvin. Okay? So now we have the equation PV is equal to nRT. Okay, so pwede natin gamitin to. PV bar is equal to RT kasi yung V mo ay V over N. Okay, so that's how you derive the ideal gas equation. So the basis of this ideal gas equation or the empirical gas equations are not very clear nung time nila. So nag-isip sila ngayon ng theory to describe the nature of the gases and why they follow such empirical parameters or empirical gas laws. So ang naging kanilang unifying theory is called the kinetic molecular theory. So in this theory, it describes that gases are random particles na nagmo-move about the system. Okay, and they have a constant speed. Okay, it's constant average speed, and their kinetic energy, their average kinetic energy can be described as something that is related to its temperature. So yun yung kinetic molecular theory. It has been considered as nonsense for 100 years, 100 and more years actually. So this is a collaborative work, okay, across this 100-year timeline. Actually, after Einstein proved that it was indeed an atom that makes up all matter, that this theory was finally accepted. Kasi, pansin nyo, 1738, it was ignored. Okay, yun yung paper ni Daniel Bernoulli. Waterstone, it was tagged as nonsense. Imagine a journal being tagged as nonsense. Joule's experiments on energetics and gas laws provided evidence for the validity of the theory, although wala pa rin masyadong naniniwala sa particle nature ng ating matter. Kahit nandiyan na ata si Dalton noong time na yon, di ba? So, attacks against statistical approach of Boltzmann. So, merong concept si Boltzmann sa statistical mechanics na S is equal to K log W. So, this particular concept of statistical entropy is based on the assumption that matter is made up of particles. So, since made up of particles siya, hindi pa rin siya masyadong pinaniniwalaan. So, nagkaroon siya, nabother siya dun sa mga attacks sa kanya ng kanyang mga detractors actually. So, since Boltzmann is a troubled man, he committed suicide, okay, partly because of this situation or this event. However, in 1905, Einstein published an article on the modeling of Brownian motion. So, Einstein predicted Brownian motion using pollens in water. Okay? So, he applied classical physics doon sa pag-predict niya ng movement ng pollen doon sa tubig. And John Perrin actually validated this claim by Einstein. So, sayang, di ba? If Boltzmann didn't take his life, he might be working on a statistical version of quantum mechanics, which is more beautiful than what we have right now. Kasi yung mga theory ni Paul Dirac and etc. ay medyo high level at hindi siya madaling maintindihan. Anyway, okay, according to the kinetic molecular theory, there are 7 or 6 particular statements. Okay, so gases are composed, number 1, of very large particles behaving like hard spheres. So kung hard spheres sila, if they collide, they do not deform. Okay? The particles move in a straight line, so hindi sila nagwi-wiggle as they travel, so laging linear ang kanilang momentum. Okay? Until they collide each other. So kapag nag-collide sila, the collision is perfectly elastic. Okay? Tapos, yung energy nila hindi na-dissipate kapag nagbabanggaan sila or kapag bumangga yung particle dun sa wall ng container. Okay? So, 3 and 4 are actually the main assumptions of the ideal gas law. So, the ideal gas law states that the size of the particles are much smaller than the distance between them and there are no IMFA that exist in the system. So, yung ideal gas law, imagine niyo yung findings ni Robert Boyle, okay? As pressure decreases, nagkakaroon ng constant value yung ating PV or yung product PV, okay? Approaches a certain constant as limit of P approaches 0. So, ibig sabihin, kapag nagkakalayo yung mga particles nyo, nagiging ideal siya. Okay? Nagiging number 3 siya. Kasi, nagkakaroon ka na ng comparison dun sa volume ng system tsaka sa volume ng particles mo. Sobrang laki na ng volume ng system compared dun sa volume ng particles dahil mababa na yung pressure. Ibig sabihin, konti na lang yung particles sa system. So, napakalayo na ng mga distances sa isa't isa. So, negligible na yung kani-kanilang volume. So, number 4, there are no interparticle interactions. Since magkakalayo na yung mga particles, Okay? Hindi na nila masyadong mararamdaman yung kanilang mga IMFA. So that's how you interpret the ideal behavior. So nangyayari din ang ideal behavior if you increase the temperature. So kapag nag-increase ka ng temperature, most of the energy of the gas is translational. Okay? And the translational energy is much greater than the IMFA energy. Okay, so isusulat ko dito. So, kung merong mga IMFA na i-exert yung gas sa isa't isa, hindi na yun masyadong significant or hindi na actually significant yun at very high temperatures. Okay? So, based on 3 and 4, okay, at low pressures and higher temperatures, ideality. Okay? Yan yung ideal conditions. So, ideal conditions. Yung low pressure and high temperature. Siyempre, kapag in-increase mo rin yung volume, okay, pwede rin increase yung volume or lower the amount of the material, of your gases, yan yung mga ideal conditions. Okay? So, yan yung mga conditions na nag-bring about to sa ideal behavior, which is 3 and 4. Ito naman yung tinatawag nating ideal behavior. Okay? So, we'll discuss more on this kapag pumunta na tayo dun sa concept of ideal gases and the consequences of being ideal. So, see you next video.